Hey everyone, and welcome to this week's episode of AI Security Ops. So, AI security tools are amazing. That is, until your monthly bill shows up and you find out that your AI triage assistant is suddenly your third highest paid analyst on your team. Why is AI and security uniquely expensive? Well, we have some techniques that can potentially save you some money when you're using AI in your environment. But first, let's talk about Black Hills Information Security, who brings you this episode. If you or your company are in need of any security service that you can think of, external, internal testing, web apps, physical pen testing, social engineering, mobile apps, embedded testing, wireless testing, whatever kind of services you might need. We also offer security operations center type services, threat hunting services. So whatever you might need, reach out to us and we can probably help you out. blackhillsinfosec.com. Additionally, we have a training branch at anti-training.com where our analysts and practitioners who are doing these tasks day in and day out take the time to package up their knowledge in a very digestible and affordable form for you to consume and hopefully help you out in your current work role or help you work towards that work role that you are dreaming of. So check them out at anti-training.com. So let's get down to business here, gentlemen. I am joined today by Derek Banks and Ethan Robish. Hey, guys.
Hey, how's it going?
Yeah. So let's talk about some of the ways that people can save money when they're trying to use AI for whatever work tasks they might have. A lot of people now are jumping on the bandwagon. They're integrating AI into daily flows. They're trying to automate a lot of different tasks with AI. But there are a couple, I think, areas that people can try to save on cost because it's easy to run up a giant bill if you're just throwing a bunch of data into AI without really thinking about how you can potentially minimize the impact on your budget. So let's talk about one of the first ones right off the bat, the right size model. What are you guys' thoughts on this of what kind of model you should use and when and how it kind of makes a difference?
Oh, I have some thoughts. This is very timely topic. So this is literally, I mean, in our notes, it talks about like the SOC, right? This is literally what I'm working on. That's why I was late to this podcast, right?
That's why we waited on you, Ethan.
Yeah. So yeah, so some of the points being, hey, the SOC gets a lot of alerts. You're running the model like very frequently, so you can't just throw the biggest tool in your box at something that's happening like thousands or hundreds or tens of thousands, whatever, like tons of times, because it's going to run your bill up, right? So approaches. I was toying with, hey, stay till the end and I'll give you one bonus tip, but I don't think I can hold it in. So here's up front. Take what you would do, your process, and use the AI agent to help you code that process, like turn it into code. I know we've talked about this on the podcast before, but like a lot of what we're doing in the SOC is deterministic, like grouping various alerts together. So the key of dealing with tens of thousands of alerts is you don't deal with tens of thousands of alerts with AI. You group them all together into cases, and then like once you have enough signal and you've got a case compiled, that's where we're bringing in AI. So we're getting like tens of cases instead of hundreds or thousands of things. So even then, getting back onto the topic of right size the model. So I'm using I have the option of several different either OpenAI or Anthropic models. So we'll just focus on Anthropic because they've got neat little like Haiku is the lightest model, and then you got Sonnet in the middle, and then Opus is like the best, the top of the line. So for the application of like, hey, do an initial pass on this case. Like this case just got created. Like do a quick triage. I'm absolutely going with Haiku. And I actually started with Haiku. I know one of the strategies we talk about is like, hey, maybe run your models side by side, like try the same prompt or the same strategies and see like which one performs better and see if it's acceptable to do the lower model. I took a little different approach. I mean, that approach is totally fine. So the approach I took was like, hey, I need to use Haiku for this. I know I need to use it, so I need to make it work. And I've gone through like tons of iterations on, what I think the biggest lever I had to pull was the context. What context does it have? But I'm going to tell you how I kind of approached the project. So basically, I took a bunch of past cases. I took all the details from those cases. I took, what was the result? It's kind of like a classic data science or machine learning type problem. Like you get your labeled data, and then I I took that and I I'm working with like Claude Opus this whole time, like designing this experiment, we'll say, and how we have it set up is we're using Claude-P to like send in a custom prompt, so that we've got a triage prompt that we're testing, and we send in the context and the prompt, and we've got the output that we want specified in the coming out. So that goes into Haiku. So we send in input, get output, and then we've got a judge. So I pit another model, the smarter model, Opus model, to judge like, okay, based on this input and this output and our expected results, which the Haiku model doesn't know, the triage model doesn't know what the expected result is. Did it come to the right conclusion? And then I run that across a ton of cases, and stop at different points to tweak the prompt, like and work with Opus to be like, hey, what are the failure modes here? Like, what patterns are we seeing? What is it constantly failing on? To tweak the prompt, or is this a context issue? Like, could it even have like come to the right answer with the data that we gave it? And if not, like, okay, well, let's go back to the drawing board. Like, how can we get this data? So that was a very long answer, but it's just exactly what I'm working on right now. So I wanted to share it. So.
Yeah, I think that also, like, it depends on how deep down the rabbit hole of coding and customization that you're going, right? Because like one of the examples that's in the show notes is like a classification problem. Like, is this phishing? A small fast model is fine. In fact, you don't even really need a transformer to detect phishing. Like, this is something that's like near and dear to my heart. I've done a lot of detecting phishing now, albeit in curated data sets that are pre-labeled, right? And so you can use and you can also train a transformer to be a binary phishing detector. Is this phishing or not? And so the same thing that can be Opus 4.7 can also be the same technology can be a small classification model. It's all in how you like train the neural network. And so, yeah, it's right that a small model is fine for that, but it depends on your ecosystem, right? Because in like what Ethan is describing, the ecosystem of Claude doesn't offer, at least to my knowledge, like a small classification model. So you'd have to like, and this is where I think like the academic and like the practical, there's not a good like path all the way like between those sometimes. And so, yeah, if you have a classification problem, there's cheap ways of dealing with it, but it depends on your capabilities, right? And so, I think that it's a great example, but I think that for most of us, practically speaking, it depends on your inference provider and like how you're set up to do. Now, I'm on the other side of the fence than Ethan these days, which is kind of fun because Ethan is the first like pen tester that we had like at a job that I used to work at a long time ago when I was at the SOC, and Ethan came in we hired Black Hills as a penetration tester. Ethan and I have known each other for a long time, right? And now, like, he's working on the SOC here, and I'm doing more like offensive work. Well, I've been doing a lot of external penetration testing type things with AI agents, like agentic external penetration testing. I started using Opus 4. I think it was 6 at the time, right when they came out with the million context window on Bedrock, and it was really expensive. Like, it was costing up to like 500, even $1,000 like per run for some of our like larger customers that I was testing with. And so I did exactly what Ethan did. I went and looked for a cheaper model. And now, using a combination of models, using some open weight models, and then like Ethan was saying, for the harder tasks, the heavier lift, use the bigger model, the right size model. So if we're making, like, I have some judges in there for like hallucinations and stuff, that's using Opus rather than GLM 5.1, which is like 90% cheaper than Opus. So we went from $500 a run to $50 a run, and that way I don't cost John Strand 10 grand each month in Bedrock inference. So
Yeah, and just bringing up one of the earlier points from Ethan too, before we move on to the next portion of talking about the deterministic portions and having it basically output code where it can. There are multiple benefits to that beyond just the cost benefit. You have repeatability, which is always great. Like, that you run it multiple times in a row, you're going to get the same result with the same input. You don't have to worry about it going off the rails, hallucinations, or you get good repeatable results as much as you can throughout the pipeline. Then let the AI do the AI stuff.
I mean, I think that's just like good general advice for working with coding agents or working with agentic stuff in security in general, right? I gave that exact advice to two different people this morning before this podcast, and kind of the same way as like what I would do is, instead of making like it determine what you're doing and figure, because it can totally go and figure it out, right? Instead, have it write a script that will go do the thing, and then have it run the script, and then make improvements as you go, right? And then also copy the script off and put it in GitLab, please.
Sure. Yeah. If your goal, your process is deterministic, and you want like repeatable results,
which is like 95% of the time.
Yeah. Then AI couldn't. You can use AI to try to do that, but you're not going to get the 100% repeatable results, which is the whole point of AI. So yeah, like use the right tool for the job, just like use the right model for the job. The other thing that I'm doing is scoping like what the agent is trying to do very tightly, rather than say, oh, hey, do all this stuff like all together, and then try to fit that into a small model. Like a large model, the top of the line frontier models, like they might be able to handle something like that, but also you're going to pay for it, versus, hey, let's just call a smaller model to do this task, and then this task, and then this task, instead of a larger model to try to do all of them.
I actually just fixed a bug in my code that was essentially doing that for a portion of it. I was like, why is this inconsistent? And when I dug into it, it was because I was essentially letting the model decide. And now there's more framework around what the model should decide. So
another benefit of deterministic, like outputting code, is you can write tests for code, and those tests aren't going to be flaky because it's deterministic. So you can try to write tests and guardrails and have other judge models like around your AI project, your engineering, but it's not always going to work, because it can just sometimes decide to do something else.
That actually kind of leads into the next one, right, Brian? I mean, the next one is this is probably tip number 4 or 5 at this point, but tip number 2 in the show notes is prompt caching. Prompt caching is important. It's a big lever you can pull. And so do you want to explain what prompt caching is?
Yeah, so prompt caching is the idea that oftentimes when you are performing tasks, you likely are using the same, if you're, all right, let me take a step back. Oftentimes, if you're going to be performing tasks in something like the SOC or pen testing, or you've put together a suite of AI tools to perform different tasks, there's likely prompts that you are reusing throughout that process. You're just changing the context that gets sent in with those prompts. So
the system
things
prompt.
Yeah, the system prompt. Yeah. So, things like rules on how to analyze a potential issue and generate an alert for it. Those instructions for doing that are likely going to remain the same. It's just the context or data that you're sending in along with that changes. And so the idea of prompt caching is rather than having the model basically see your prompt for the first time every time you send it in, it can cache that on the back end, and it does two things. One, it reduces lag time because it's already cached, it's already done a certain level of processing up front. But in the spirit of this episode, it can also save you a lot of money. It's somewhere around potentially like 90% of costs in terms of processing that section of text. Now, any of the new text you send in, obviously that has to get processed as it were seen for the first time because it basically is. But you're at least, I mean, you run these queries over enough times over a length of time. Every little bit adds up, especially if you're using the higher powered models for a lot of this stuff. So I think that's the idea. Um,
I think I think there's a key point here that I want to stress or call out. So when we think about like request caching in like the web world, we think, oh, you make the same request or databases, like you make the same query, the results are cached so they can be returned faster. But that only works when it's like the same. But here with prompt caching, it's actually like a spectrum, right? It's like from the beginning, how much have I seen before? Oh, here, this is the first new token. Okay, we can cache everything up till here. So changing your data later, it doesn't bust the entire cache. Like it will bust it up until or like until the point where it changes. So that's why you can actually take advantage of this rather than thinking, oh, well, I never send the same prompt to the AI. Like, how could I even get any benefit of caching? Like, it's always doing something different. But no, the point is like, and harnesses take advantage of this too. They put like the system prompt that doesn't change up front. They put the tool calls that don't change up front, or that not the calls, but the tool definitions, like the skills that those are all loaded in the order of like this is least likely to change, so that it can take advantage of the processing, the caching.
And if that sounds like foreign to you, come take my class on how large language models like work, or Brian and I's class in October of this year, because knowing how these things work when you're engineering solutions around them is very important. Like, why would I want to cache? Like, why would that even matter? It's because how LLMs like how they process token by token and like how they predict things. And so your explanation, and I think, was spot on there, Ethan.
Thanks. I actually made this mistake not too long ago when I was using, I was sending a prompt. So it had a system prompt and a user prompt to the agent. And I thought when I first started that, oh, it would be a really good idea to customize the system prompt. So I put a variable in the system prompt, like, oh, hey, this is you're looking at this type of entity, and here's the host name. Just as the example, I inserted the actual host name into the example that it was supposed to use. And I realized later, like, oh, I am busting the cache every single time doing this. Maybe I better stop doing that and rework my prompt so it can just stay static. And yeah.
Well, that's why, and I've said this many times, when you get into coding around large language models and trying to solve like problems and do, especially like enterprise level problems, I've not found a bottom to where this all ends. Like, I learn new stuff every day, and it's really fun. All right, so the next one, tip 7 or 3, batch API for anything that's not urgent. And this is actually one that I've not personally used. I haven't tried batch processing, but the idea is that you have, you want to get output for your input, and so like with a call as API, you can like batch stuff, and basically it'll work on it overnight. So that way, outside of peak hours, they give you a reduced rate on the inference, right? So
Yeah, like I'm assuming similar to like electric companies that they might charge a different amount for
yeah.
when everyone's home with the air conditioners firing versus, during the workday or whatever. So,
Wait, are
Yeah.
you saying that AI access is a utility, Brian?
It
Ooh,
won't be long until we look at it that way, I think.
yeah, maybe.
Just as a side note, my dad lives in a pretty rural area and he just recently got like fiber, like broadband. And up until this point, he was using LTE and he had, gigabyte caps and, data caps and stuff. And so basically that whole county, it was in, like they had a municipal effort, like a government effort to get broadband everywhere. And so I wonder how long it will be. I mean, this is really like an education thing. Like the kids that were in the county, like were really suffering with not having high speed internet access in the modern world. Right. And, and so I wonder how long it's going to be until we look at AI and inference as the same thing, right? Probably not very long. All right, here's tip number 4 or 8 or whatever number we're on.
You're counting like an LLM.
Yeah, I know, right? Well, LLMs are very bad at arithmetic. That's just sort of how they work. Like they're good at math if it's word math, right?
Yeah,
But
logic,
logic,
reasoning.
yeah, not so good at the actual arithmetic. You would want to this. I've given this advice too. Well, how come the LLM can't count? Well, what you need to do is get it to write a script to count, then it'll count fine every single time, right? Like that's what you do. But this tip is stop dumping entire logs or entire sets of data and curate your data first, right? And so basically here the idea is that you don't want to put the entire log in. You want to put in stuff that's relevant, which maybe is like security advice from the past anyway.
I would say in addition to cutting costs, it also improves accuracy. Like if you tailor your context to what is actually needed, and that goes back to my testing of like, hey, what context is actually needed to get the result I want? That it makes a huge difference. Like you can fit more relevant, like denser data in if you're tailoring it, and you're not just dumping everything and then it picks on some irrelevant detail and anchors on that, and then your result is just like way out of whack because you gave it too much and it got confused.
Yeah, it's like an inverse pyramid of pain where you have like the raw data and that's coming in, and then like 95% of your data is like just stuff you've seen before. Like we know this is fine, right? Like this is a log entry we don't care about. So those 95% of it's gone, right? And then you take that other like 4% and you apply machine learning, statistics, AI, or whatever. And then what comes out of that, a human applies domain knowledge to find the 0.01% that's malicious, right?
Speaking of human knowledge, domain knowledge, if you're struggling to figure out like what context should I put in, what should I give it, think about what information you would need to solve this problem. Like whatever problem you're wanting the AI to do, to whatever process you want it to take, what would you need? What would a human need to do that? Because the AI is going to need the same information, and you could even talk with it like, hey, what are we missing? Like here's what I'm thinking for what is required to accomplish this. Like what don't you need out of this, and what am I missing? Like talk to it. Talk about how to design the workflow that it's going to follow.
That's
Yeah,
surprisingly successful.
yeah. Well, yeah, I mean, same concepts as with like traditional machine learning or traditional classifiers, if you will, right? Like more features isn't always necessarily better. And typically one of the steps is determining feature importance. So you
Oh
got a
yeah.
bunch of data with a bunch of features. You run it through your classifier. And then with things like random forest classifier, it's built right in. With others, there's methods to pull out the same information, but you can get a measure of feature importance. Like, okay, you arrived at this decision. Which of these features were actually relevant to arriving at that decision? Okay, out of these 1,000 features, these 50 were important. I can get rid of the other 950 because they're not doing me any good. And to Ethan's point on accuracy, might even be making things worse. And in this case, they're just costing you extra money. So,
Oh man, I'm having flashbacks to statistics 501 and running relevancy tests and such. Oh god.
So the awesome thing with LLMs is if you don't understand anything that Brian just said, just pick out some words and ask the LLM like, hey, I want feature extraction, feature importance like for this problem. Help me with that.
Well, there's a lot of tips in here. So the next tip, is RAG instead of stuffing. I've actually not used RAG with agents very much, but I get the idea behind this is don't waste the whole library when you can just get the relevant page.
Yeah, I would say this is pretty much like an extension of the last tip, where
Yeah.
designing the context rather than like being very specific versus giving it everything. But just talk instead of like raw data, raw events, raw logs. It's talking about like reference material, like the documentation. And
Right. Then the next one, we've actually talked about this one already, and that's dedupe and cache the responses. Your SOC sees the same alert pattern over and over. Don't ask the AI every single time. Yeah, I mean, if you know that this is not likely going to be malicious, don't send it to the AI. Or if it's not relevant to the context, rather.
Yeah, and I think that brings us to the final point here, which isn't really not necessarily a cost-saving tip so much as a safeguard, so much as a help you stay solvent type tip.
Not
As a
get angry
company.
phone calls from the people who sign your checks.
Yeah, which is setting basically setting budgets and circuit breakers. So and we know that Bedrock has the ability. I'm sure like Azure and probably others have the ability to set a cap on how much you're spending per month, which is a good idea to put into place because if you're not careful, especially if you have a large company or you're running a lot of complex tasks and not taking advantage of some of the tips that we mentioned earlier, it's very realistic to run up a eye-popping bill at the end of the month. So putting in safeguards of saying that no, like we're not going to spend more than this amount of money, cut it off. If we hit this limit is a good idea. And if you reach that limit, then you can
Have a
reconsider what's going on.
conversation. Yeah,
Yeah.
right. I mean, and it's also good, in the unfortunate circumstance is if the key somehow got leaked or stolen, right? Which is definitely something that happens, right? And we all like to think, oh, it'll never happen to me. Well, I don't know, right? I think Light LLM would have something to say about that, right?
A few episodes ago, we talked about like shadow API brokers for
Yeah.
AI, and I mean, I would not be surprised if a lot of those are being served by stolen keys.
Yeah. And so I think that, setting caps and limits like that's a necessity, like it's an operational necessity.
Yep.
It's what we do.
Yeah.
For
Oh,
sure.
absolutely. All
All right.
right.
So rapid fire recap: right size model, prompt caching, batch API, pre-process your logs, RAG over stuffing data into the LLM, cache verdicts, and instrument and budget.
Those are all
And
good.
bonus
Good,
tip,
useful.
And a bonus
uh,
tip.
bonus tip: convert your processes to like deterministic code. Like have AI write the code, and then you paid once, and then you don't have to pay the AI inference again.
Yeah, I think that in general, I try and limit the AI processing to things that I would have expected a human to do, like investigate this and report back what you find, kind of thing. And everything else really. I mean, finding that spot might take trial and error, but I think that 95% of your harness or your code should be deterministic, and only like 5% of it should be AI, I
And
think.
there's nothing saying you can't start with a broader like
Oh,
AI
yeah.
solution, and then after you get some results and you get some data, you can make it a project to go look at and analyze that for patterns, and you can pull out those patterns and codify them and reduce the amount of work that your overall general AI has to do.
All
Cool.
right.
So, yeah, I think these are all great tips and points, and I hope that certainly help out some of the people out there, things that you can integrate into your daily workflow at your company to save some money. So, hope everyone enjoyed that, and we'll see you next time. And what's the line, Derek?
Keep
Let's
on
hear it.
prompting.
Keep on prompt.
Now it might be more like keep on context engineering or keep on harness creating or
Creating.
something.
Yeah, just keep on doing the things.